So, one second, beta. So, welcome to my YouTube channel, and I guess you know now. Today we are discussing the last part of capacitor, right? Am I audible and visible to all of you? So, welcome to my. So we are having a last lecture of capacitor as we discussed it earlier, right? In the 4 classes, we will be completing the whole thing. So from day after tomorrow, we will be starting a magnetism. So let us start today's chapter. One second. One second, Vito. So let's start now, the last one. Okay. So in the last class, we discussed about if we are connecting two capacitors with the same polarity. So this formula we need to use to get the numericals done. This one is C1 V1 C2 V2 by C1 plus C2. If we have the different polarity, so I will write C1 V1 plus C2, and then it is V2 will be minus there. Okay. So that that way you need to just manipulate your answers. Okay. So now today we are discussing RC circuit. So we are going to discuss RC circuit. Last class, I will write here. Last class. Last class. Topic is RC circuit. First of all, not important. This particular topic is not important. Okay, it is not important. But still, you need to get some sort of information about how RC circuit work. One second, one second, one second, one second. Okay, now what is basically RC circuit? What is basically RC circuit? So in RC circuit, we have two electrical components. One is the resistor. One is resistor. Second one is capacitor. Second one is capacitor. So what we have, resistance, then capacitor connected with external voltage source, then some sort of key, right? So if the EMF or the voltage of the external one is, let us suppose V, okay, resistance is R. You can see here, this one is at high potential, this one is at low potential. If this is at high potential, so this one would be positive, this one will be negative. Then okay, now we will use Kirchhoff's law. We will use KVL for it now. Use KVL. Okay, so let us close the switch now. Current I will flow through this one, so the potential drop here will be minus IR. So potential drop across this one would be, we know that Q is equals to CV, so V came out to be Q by C. Then if it is capacitance is C, so I will write Q by C but negative. Why? Because we are going from positive to negative. So how I will write it? So it is minus IR minus Q by C plus V equals to 0. This is my equation. This is my equation. If I need my charge Q, okay, the final expression that you need for any numerical derivation is not important. So if you need Q, so Q is equals to CV 1 minus E minus T by RC. T by RC. What happens to it? 1 second, beta. 1 second. 1 second, 1 second, 1 second. It got stuck. Okay. RC. Okay. So the expression that you need to remember, no? So this is the final expression that you need to remember. So my charge is equals to my charge. So my charge will be equals to how much? It is charge Q, capacitance C, voltage V, 1 minus exponential of minus T by RC. Minus T by RC. So look now, you will get some numericals based on this particular equation. That means first case is at T equals to 0. T equals to 0 means switch is just closed. Switch is just closed. If the switch is just closed, we need to find out charge. So what is the equation? That Q is equals to CV 1 minus E minus T divided by RC. Now place the value of T as 0. I can write Q equals to CV 1 minus E minus 0 by RC. 0 by RC is 0, obviously, so I can write Q equals to CV 1 minus E 0. Something power 0 is 1, so I can write Q equals to CV 1 minus 1. So Q came out to be CV multiplied by 0. So my charge came out to be 0. So the meaning of this expression is when you are just closing the switch, means when T is 0, my charge across the capacitor is also 0. My charge across the capacitor is also 0. Okay, sir, second part, case number second now. Look now. Case number second means when my time tends to infinite, means steady state. Use equation Q equals to CV 1 minus E minus T by RC. I can write Q equals to CV 1 minus E minus infinite by RC. I can write Q equals to CV 1 minus 1 divided by e to power infinite. Look, it is infinite by RC. So infinite by RC is all approximately equals to infinite only, no? That is how we have 1 lakh crore divided by, let us suppose, a small number. That will be also in crores, no? That is infinite by RC is also equals to infinite only. Okay. So do you know what is the power of e to the power infinite? So I can write here 1 divided by e to the power infinite. This particular term is how much? Any idea? Something power infinite, no? It will be infinite. So what is 1 by infinite? So you can see now this whole term will become now 0. This is 0. It is 0 now. Okay. If this is 0, so I can write Q equals to CV. This is maximum value. When your time tends to infinite, your capacitor is maximum charged, maximum one. It is maximum charged. Done. Now, third case. These cases are predefined. Predefined means you will get either a case of T equals to 0, T infinite, or T equals to RC. This particular RC means time constant. It is time constant. You will get this term very commonly used in my EMI chapter. Okay. So look now, my equation will be here. Sir, Q equals to CV 1 minus E minus T by RC. So I can write Q equals to CV 1 minus E minus RC by RC. So look, I can write here RC cancel out. So I can write Q equals to CV 1 minus E minus 1. So Q equals to CV, I will write 1 minus 1 by E. Do you know what is the value of 1 by E? 0.37, no? Something like that. Okay. So I can write Q equals to CV 1 minus 0.37. So my value for Q, so my Q came out to be CV 1 minus 0.37 will be 0.63, no? It is 0.63. Yes, that means my time constant is that much of time at which my charge will be 63% of maximum or C. Okay. Sir, what is time constant? It is that amount of time in which my capacitor will get charged up to 63% of the maximum one. What is maximum? C. So if you need to draw a graph of it, okay, the graph, this graph is important. Graph between time and charge Q. Look, when my time is zero, look, time is zero, my charge is zero. Second point, time is infinite, charge is maximum. So that simply indicates it is an exponential graph. My time zero, charge is zero. So the graph will looks like this now. Look, it's my graph. When time tends to infinite, we will be having what? A maximum value. That means how? CV. And here you can write, sir, this means it is time constant. When T equals to RC, this one is my time constant. It is 63% of CE. CV or CE. Done? Done now? Now you will find lot of numericals. Okay, in your module or in your DPPs, in some standard books also, you will find some numericals based on the RC circuit. Okay, so I will be giving you a trick. I will show you a trick how to solve a numerical. Okay, how to solve a numerical. When when asked when asked T equals to 0, first point. Second point, T equals to infinite. When T is 0, replace capacitor with wire, conducting wire. When T is 0, replace capacitor with gap. These two things you need to remember. These two things you need to remember. What, sir? If in a numerical it is asked that switch it just close it, that means T is 0. So you need to replace the whole capacitor with a conducting wire. Second part, when T tends to infinite, you need to replace capacitor with gap. So what is the meaning of it? Let's suppose we have a numerical. We had a numerical. Numerical looks like this. Look now. This is my numerical. A simple numerical. Okay. E R C. And it is asked first part. First part means when T equals to 0, find current. Find current. That means we just closed it. So we need to replace capacitor with wire. So I can write it like this. E R. So I can use Ohm's law. V equals to I R. No? V is E. R equals to I. So this is my answer. Look here, we replace this part. No? We replace this part with conducting wire. So the answer is very simple now. You can see here the answer is very simple now. Very simple. Within 20 seconds, you will get your answers. The second part. Second part is same na B part. When T is infinite. So what you need to write? Sir, gap. It is a gap. Gap means incomplete circuit. Okay? Incomplete circuit. So no current flow. So I will be 0. Current will only flow when the circuit is closed. This is open circuit now. You can see, sir, it is an open circuit. This is particularly what? An open circuit. If it is an open circuit, so current is 0. Simple topic, no? Very simple. So if you 1 second. Now second part. Or a numerical. Let us do a numerical. Let's do a numerical. Okay. Numerical is 6 volt, 24 ohm, 8 microfarad. Given T equals to 0. Find current. Find current. So how we need to deal with it? Sir, simple. Redraw the structure. Redraw it. It is 6 volt, 24 ohm. Ohm's law. V equals to IR. V is 6. R is 24. It is I. 6 is R. No, it is 36. No? 6 fours. 6 fours 24. So I came out to be 1/4. That means 0.25 ampere. Easy. So we just changed the whole numerical from 12th class to 10th class. This is 10th class numerical, no? 10th class one. Okay. Sometimes now look. Sometimes you can see here now. You can see here, sir. This equation is basically, you can see, sir. This equation is basically a current equation. Sorry, the charge equation. This is a charge equation. If instead of charge you need to get current, then how we need to do this numerical? If instead of charge now we need to find current, so how we need to do it? Look better. Okay, last class hardly it will take 20 minutes, then we will be done with it. Okay, let's suppose now look, you will get the value. Sir, my current came out to be 0.25 ampere. Okay, so the numerical is when you just closed the circuit, that means at time 0, current value is 0.25 second. Let us suppose second numerical is after 5 minutes. You will get a numerical after 5 minutes, find the value of current. Okay, no? So we don't have any equation by which we can place the value of time and we will get the current. So for that thing, what we need to do? So you can simply see, sir, my equation that we know, sir, Q is equals to CV 1 minus E minus R divided by T divided by RC. It is T divided by RC. So what is current, sir? Current is dQ by dt. So I can write d by dt and Q came out to be CV 1 minus E minus T by RC. Okay. I will take, look, CV is constant. I will take CV outside. Differentiation of 1 is 0. Then minus differentiation of exponential function. So if we have e to the power x, it is differentiation. Its differentiation is same e to the power x. Then differentiation of power. That means it is differentiation of, I will write like E minus T by RC. Okay. So I came out to be minus CV, whole term same, then differentiation of power. Okay. I equals to minus CV, E minus T divided by RC. 1 by RC will take outside, then it is differentiation of minus T only. So I equals to minus CV e to the power minus T divided by RC. Then whole RC, differentiation of T is minus 1 only. Minus 1 cancel out, CC cancel out. So I came out to be is what? V by R e power minus t by RC. This is my value. So this equation is all about the relation of your time with current. So what is my equation now? Look, I have two equations. One equation is charge. So, sir, I will get charge. Q equals to CV 1 minus E minus T by RC. That means, look, C is given, V is given. I will get my charge. So, find the charge across the capacitor when my time is 6 minutes. Okay. One more. I equals to, it is V by R, E minus T by RC. This equation I need to use to get my current. I need to use to get my current now. So if you want to get the current, you need to use this one. Very simple. Suppose you will have a numerical. Numerical states that find current in time constant. That means my time is equal to time constant. So T equals to RC. No? So what is current? Sir, current is V by R E minus T by RC. Done. So I equals to V by R E minus RC by RC. So I can write I equals to V by R E minus 1. So I equals to V by R into 1 by E. I equals to V by R, it is 0.37. So you will put the value of V and R, you will get the current I value. Okay. Okay. So let us do one numerical. Let us do a numerical. Now you will see now, you will have a multiple ways to do a numerical. Multiple ways. Now you have multiple ways, multiple approach to complete a numerical. No? Look here, we are just using capacitors and current electricity. First part, T equals to 0. Second part, T equals to infinite. Then, in both cases, find current. Both cases, find current. First case, when T is 0, so how we just do it? I need to redraw the whole structure. So instead of this one, I will use a plain wire. Then 1000 ohm connect, done. 2 volt. So if you need to get R equivalent, what is R equivalent? From, look, no need of this one. Why? Current will flow through this one only, no? And we had done this numerical in current electricity. So R equivalent is 1000. Okay. So V equals to IR. I came out to be V by R, which is 1000. I came out to be 2 milliampere. Second one, T is infinite. If T is infinite, so I need to write it like this. I will write it like this. 1000 ohm. 1000 ohm. 2. Now what is R equivalent? R equivalent is 1000, 1000, 2000. It is 2000. V equals to IR. I is V. V is 2 by 2000. That is 1 milliampere. Look now, if you are done with this topic, so it is very easy to get these things done. Okay? Any doubt? Now, last numerical. Last numerical of capacitor. Last numerical. And last 5 minutes of time for this particular chapter. Okay? Look better. We have system. Done. We have given if t is equal to infinite. That means steady state. Steady state. Steady state means open circuit. We know it, it is open circuit. We need to find charge. Charge. Sir, how we can get it? Look, if it is steady state, so what I need to do, I will make it like this. Open circuit ना बेटा. Look, E R R2 R1, point A, point B. Done. Current I will flow through this one and I will get into it. I here. No current flow through this branch. I here. Because to get the current flow, na, there should be a complete circuit. Look, you will see here gap. Na, this is gap between A and B. So can I write an equation for this one? Can I write an equation? So what equation? VA. I will go in this way. Look, I will go in this way. It is VA, then minus IR2, then minus 0 times R1 equals to VB. So VA minus VB equals to IR2. So delta V equals to IR2. So delta V equals to IR2. Okay. This is a battery. Now it is a battery. So do you know the equation for battery? V equals to IR. What is I? E divided by R net into R. What is R net? It is only R2. Why? Because current is only flowing through R2. No? I will write delta V equals to I. I is how much? E divided by R2 plus R multiplied by R. What is this R? R2 only, no? And what is Q? Sir, Q equals to C delta V. It is C delta V. So what I need to Q, no? So Q came out to be C E divided by R2 plus R multiplied by R2. Or Q equals to C E R2 divided by R2 plus R. So by this numerical, I will say that we completed capacitor also from 0% to 100%. Now, what is your duty now? Okay, DPP is from any institutions. You have your module. Then you have NCERT. From NCERT solved and unsolved. Okay, you need to do all these things. And definitely I will be just starting a series on NCERTs. Okay, in which I will be discussing solved numerical and unsolved numerical from NCERT. But you need to do it from your end also. Okay, I hope you enjoyed this session. If you have any doubts or if you want to ask me anything, you are most welcome. If not, then bye, good night. So definitely you need to just revise the whole chapter. So from day after tomorrow, we will start magnetism. And we have this aim now that we will complete the whole syllabus before next month. Okay. Thank you for your support. Thank you, Veda. Thank you. So if you want to ask me anything, you are most welcome. I will wait for a couple of minutes. One second. Okay, so I guess you don't have any sort of issues or you don't have any confusion, right? So what we can do, we will just end the session, and I hope that you will do your homework and all these things. You will complete these things, right? So um, this 22 from 24 we will be starting magnetism. Okay, and we will complete the magnetism within let's say 1 week. I need to take the time 1 week. Okay, within 1 week we will just complete magnetism. Then we have magnetism, EMI, AC, then EM waves, optics, dual nature, atom nucleus, semiconductors. So it will take more than 1 month, right? But not that much. So then we will start 11th one. Okay, because I have many things to start now. I will start the NCERT series. I will start the top 1000 numerical series and top numericals from each and every chapter. So that thing I have in my mind, but that will take some time to get implemented. Okay. So bye, beta. Good night. Bye. Thank you. Take care.